All right, so we know that a function rule will produce ordered pairs of input, comma, output. So what we're going to do now is we're going to take a function rule like f of x is equal to 2x minus 3. We're going to come up with the ordered pairs input, output, and we're going to plot those points over here to see what our function rule would look like as a graph. So to do that, we're going to find ordered pairs, we're going to graph them, and we're going to connect them. You have to use a little bit of common sense in making a decision. Do I have enough points plotted that I can determine the shape of the graph? And as you go through your study of math, you will find clues to when you have that graph correctly or not. We're going to begin our study right now. So let's start with this first one. So 0 is always a nice number to start with as an input. So I'm going to input a 0 over there and get 2 times 0 minus 3. So that's 0 minus 3, so that's negative 3. And it gives me the ordered pair 0, negative 3. So we'll go to a 1 and get 2 times 1 minus 3. 2 minus 3 is negative 1. Ordered pair is 1, negative 1. So maybe let's go to the negative side. So negative 1, we get 2 times negative 1 minus 3. So a negative 2 minus 3 is negative 5, and our ordered pair is negative 1, negative 5. So take a look. We're going to plot these. We have 0, negative 3, which is, it's going to hard to show up with this, is right here. And then I have 1, negative 1, which is right here. And then I have negative 1, 2, 3, 4, 5, which is right here. It appears that these are going to be a straight line and that we'll be able to connect them. Just to make sure, you might try something like a 5. Let's put in a 5 just to see if it falls on that line. So then I get a 2 times 5 minus 3. So 10 minus 3 is 7. And I get the 0.57. So 5, 1, 2, 3, 4, 5, 6, 7. And you can kind of see that this is going to graph to be a straight line. You might try negative 3 as well. I'm not going to do that right now, but it's going to end up being a straight line. You can't always assume that. There's some shapes that have straight lines in them, but they're not totally straight. So that's what my graph looks like. All right, so let's go to example C here. Because it looks a little bit different. So let's go ahead and talk through that one. I'm going to start off with 0 because that's just so easy. And then I get the absolute value of 0 minus 2. So that 0 minus 2 is negative 2, and our ordered pair is 0, negative 2, input, output. If we input a 1, we get the absolute value of 1 minus 2. So that's 1 minus 2, which is negative 1, so I get 1, negative 1. If I put in a, we'll go ahead and do a 2. If I put in a 2, I get the absolute value of 2 minus 2, so that's 2 minus 2, which is 0. So I get the ordered pair, input 2, output 0. Now let's go back and do negative 1. So the absolute value of negative 1 minus 2. Well, the absolute value of negative 1 is positive 1. So positive 1 minus 2 is negative 1. And I have the point negative 1, negative 1. And I put in a negative 2, absolute value of negative 2 minus 2. So the absolute value of negative 2 is positive 2. Positive 2 minus 2 is 0. And I get input negative 2, output 0. So let's plot those points. So the first one is 0, negative 2. Then I have 1, negative 1. And I have 2, 0. So at this point, it's looking pretty much like a straight line, right? But it's not. When I go to the next point, I have negative 1, negative 1. And I have negative 2, 0. So right now it kind of looks like straight lines, two different directions. So we might toss in maybe a 5 and just double check it. If I put in a 5, I get the absolute value of 5 minus 2, so 5 minus 2 is 3, and I get the 0.53, so 5, 1, 2, 3, and you can kind of see this is going to make a straight line here. And if I did the same thing on the other side and chose a point down there, I would see that this also makes a straight line that direction. Absolute values always form a V. So whenever you're working an equation that has an absolute value, you have to search for where it makes that V point down there.